Hello everybody. So, we're finally getting into integrals. And particularly we're going to start talking about double integrals over rectangular regions. This is about the simplest case that we're going to be dealing with for double integrals, so this is where we're going to be starting with them. They are going to get a lot more complicated, but the basic ideas won't be changing. So how are double integrals different than just a regular integral? So first of all, let's look at what a 2D integral is. It's written like this, so it's the integral from a to b of the function f of x with respect to dx. Pretty straightforward. So x varies from a to b. If you look at the picture of it, it looks like something like this. And all you do is you add together all of the area. Now, if we go into 3D, you end up writing it this way. The integral from a to b, then the integral from c to d of the function f of xy with respect to dy, then dx. Now, you have to keep things straight here. You have to work from the inside out. So the CD integral actually goes with the dy. So you can ignore the very first integral and the dx at the end until you are done with those parts. And instead of our total thing being the area, you can probably guess that this is going to be a volume. Now, so this shows that x varies from a to b, and y varies from c to d. And then all you do is you add up all of your volume instead of just adding up all of your area. So however many integrals you have, that's going to tell you how many additional dimensions you are adding. The interior is always just going to be talking about the height, though. So the height of this graph is this interior part. And then you're just integrating it over those two areas. Now, thankfully there's some nice properties for integrals when you have more than one of them. So you can keep those in mind. First of all, if you have a constant multiplied by your function on the inside, you can just pull that all the way up to the outside, and it's still going to give you the same result. So you don't have to worry about that. Now, also, if you just have two functions added together, being integrated, you can integrate each separately and add the results together, just like back in Calc 1. Now, another thing. If f of x is continuous on the rectangular region, so x goes from a to b and y goes from c to d, then you can easily switch the integrals and the differentials. So instead of integrating with respect to y first, you can decide instead integrate with respect to x first. Now keep in mind, when you are doing these, you're doing it the exact same way you do partial derivatives, which means you're holding the other values constant, such as when you're integrating with respect to x, well, y is a constant, so the integral of that would be yx. All right? Hope you guys learned something from this, and I will see you in class.